One of the most common ways to represent a line or on a graph is in slope-intercept form, where y equals mx plus b. M is your slope, the steepness of the line, and b is the y-intercept, where the line crosses the y-axis. So in the example, y equals 2x plus 7, the 2 is the slope, the line is changing up to and over 1, and the y-intercept is 7. It crosses the y-axis at 7. So let's look at finding the slope and the line equation of a line for a specific graph. If we have a graph with the points 3, 9, and 5, 5, we want to figure out what the slope is between these points, and find the y-intercept of the line through those points. So we'll start by finding the slope. Remember, the equation for the slope, m, is y2 minus y1 over x2 minus x1. Because you're calculating the change in the y. How much is your graph rising up and down? And then the run. How much is the graph going side to side? x2 minus x1. So if we put in the y numbers, we can select the y's. 5 minus 9 over, subtracting the x's, 5 minus 3. 5 minus 9 will give us 4. 5 minus 3 will give us 2. Reduce your fraction. The slope is 2. So if we try to write the equation of our line, y equals 2x plus the y-intercept. Oh no, we haven't found that yet. So we'll just fill it in with the b still. But now we know almost everything we need. We have found the slope, 2. We have a point on our graph, 3, 9. That's going to tell us both the x and the y of a point that would have this y-intercept. So we're going to substitute them into our equation. For the y, we can substitute in the 9. And for the x, we can substitute in the 3. We still don't know the b. Now we have every variable filled in except for the b, and we can finish solving. Simplifying, 2 times 3 would make 6. So 9 equals 6 plus b. Subtract 6 on both sides to solve for your b. Cancels out. 9 minus 6, 3 equals, all that's left is b. So now we know our y-intercept would be at 3. So for our graph with points 3, 9, and 5, 5, we would have an equation straight through those at y equals a slope of 2x plus, and the y-intercept would be at 3. There's our equation. Now we're done. If we continue, there is another form and equation. Oh, this is not what I wanted. Here we go. Our other equation can be seen down here, the point-slope form. In this case, you have a slope still given to you as m, but instead of being told the y-intercept, instead you have a specific point from your graph, x1 and y1. So if you had the equation y minus 5 equals 2 times x minus 7, in this case, we would know that the slope is 2. The slope is 2, and there would be a point on our graph for this specific line that would be at x equals 7, 5. Let's look at an example of what would happen here. We're going to write the equation of a line through the point 4, 2, and with a slope of 3. Now, just like in our previous problem, we could use 2 points and calculate the slope, using y2 minus y1, x2 minus x1, but in this case, they told us the slope was 3. So in our equation, instead of doing your typical y equals mx plus b, we're going to do point-slope form. Y minus y1 equals m times x minus x1. If we fill it in, our point already gave us an x value and a y value. So our equation is simply y minus 2 equals the slope of 3 times x minus 4. Now we didn't have to do that extra work to solve for the y-intercept. If you wanted to, we could. I could distribute the 3. Y minus 2 equals 3x minus 12, and solve for the y by adding 2 on both sides. And now I have y equals 3x plus 10. Both of these equations are the exact same line. They're just written in a different format. You're allowed to choose whichever method you prefer.